Hello students, here's 13.2 lecture. So first of all, please remember that for most gases, we're going to assume they're going to behave like ideal gases. That is, they can bounce off each other without losing any energy. And regardless of the type of gas, you're going to get about 22.4 liter in 1 mole, okay, at standard temperature and pressure. So once again, STP for gas is that at normal standard temperature of 1 atmosphere and a temperature of 273 Kelvin, you get roughly 22.4 liter of any gases at 1 mole. So what's an ideal gas? Once again, an ideal gas is a gas that have perfectly elastic collision. They do not slow down when they bounce off each other. And they are not attracted to each other in any way though. So the main equation you're going to use for today as well as for other things in the future is called the ideal gas. This is the equation right up here. And that's what the variable defined at. There are going to be different R value that you're going to use based on the different situation. So if you are given a problem related to atmospheric pressure at ATM, you would use that. If you're given a problem with kPa, you would use the second one with 8.314. And if you were doing a problem somewhere in Europe, for example, and you were using millimeter mercury, you would use 62.4 liter millimeter mercury per mole Kelvin. So depending on what the problem is giving you, you would use one of those three R value. Now, if you were not given one of those pressure, you have to convert it to one of those pressure and pick the appropriate R value. So let's try to do this one. What is the temperature? So I know I'm looking for temperature. Okay, I have 2 mole, which is N. And I know pressure is here, and this is liter, which is volume, okay? So it's PV equal nRT. The R we would use is this one because the unit for pressure given is ATM. And that is the reason why I picked that one out of the list of the 3. Now, what are we looking for? At what temperature? That is my question mark. So I'm looking for T. That means I want T by itself. That means... So how do I do that? I gotta get rid of N and R next to it because N and R is both multiplied to it. That means you divide to get rid of them. And whatever you do on one side, you do onto the other side. So that means that T is equal to PV over N and R. Now it doesn't matter you put all N or NR since multiplication does not matter the order. So let's plug it in. T is equal to P, which is 2.50 ATM, times V, which is 15.00 liter, divided by R. In this case, we choose 0.0821 liter multiplied by ATM over mole dot or multiplied by Kelvin. Okay, and that is multiplied by N, which is the number of mole, which is 2.00 mole. So before you punch anything out, cancel unit to see if what you're looking for makes sense. If we're looking for temperature, it should be Kelvin or Celsius. So ATM cancels out. Liter on top cancel out with liter on the bottom. And here, if I extend this line, this mole is on top of that line and this mole is in the bottom. And that cancel out. So the only thing I have left is a division of a division, which is Kelvin, and therefore that flips it to the top. So now I just grab my calculator and punch it out. 2.50 times 15 equal, divided by 0.0821 equal, divided, once again, divided by 2.00, because anything in the bottom of the main line has to be divided by. And I end up with 913.5 degree Kelvin. I could round it off to 914. Either one of them will be accepted. Since I'm looking for temperature, I end up with Kelvin. Here we're looking for how many mole, which is N. Okay, and we have pressure, volume, everything is listed right there, so we can see that. Now, why do I pick this R value? Is because the pressure is in kPa. Okay, so once again, PV equal N, R, and T. And what are we looking for? We're looking for N. So that means I gotta get rid of RT by dividing it, since it's the opposite of multiplication. And whatever you do on one side, you do onto the other side. So we know that N is equal to PV over RT. Okay, just in case some people think that's a J, let's erase that. So let's plug it in. N is equal to P, which is 172.5 kPa times V, 5.05 liter, divided by all, in this case we choose 8.314 liter dot kPa over mole dot Kelvin. And that whole thing is multiplied by temperature, which is already in Kelvin, so I don't have to convert it. So let's see what we can cancel out. We can cancel out kPa, we can cancel out liter, and this Kelvin is on top, and this Kelvin is in the bottom of this line right here. So what are we looking for? We're looking for mole, and the only unit I have left is mole, because it's the bottom of the bottom, that means it's on top. So double bottom means on top. So now punch it out. I go 172.5 times 5.05 equal, divided by 8.314 equal, divided by, so let me double check again because my answer seems a little big. My finger must have touched something. So once again, 172.5 times 5.05 equal, divided by 8.314 equal, and divided by 353. And I ended with 0.2968. So roughly 0.297 mole. So by rearranging that equation and having different representation, you end up with 3 modified equation that is derived from that. Here are the 3 equations with what the letter represent. Once again, the molar mass is the mass that you find on a periodic table. So for hydrogen, it would be roughly 1.008 times 2, because hydrogen gas is H2. Okay, the only mass that you keep originally as is the noble gases. But don't worry about that. It'll be clarified if that was on the test. So what is the density of a helium in a container? Okay, so I'm looking for D. D is already by itself, so I don't have to rearrange it. I can just plug it in. Okay, what is molar mass? So I go on the periodic table and I find helium, and it's roughly 4 grams per mole. It is a noble gas, so I don't need to multiply it by 2. Okay, P in this case is 2.0 atm divided by the temperature and the all value. Now, which all value would I pick in this case? Would I pick 0.0821, 8.314, 62.4? I look at it, my pressure is atm, so I would pick 0.0821. And the unit is liter, atm over mole dot Kelvin. Okay, and the last thing I have left is T. Temperature is already 300 Kelvin. I don't have to convert it to Kelvin at all. So let's cancel out some unit. Mole, atm, Kelvin, and density should be mass divided by volume. Do I have a mass? I do have a gram left, and I do have a liter left. And if you can't spot it, it's right there. Okay. So let's punch it out. We have 4 times 2 divided by 0.0821 equal, divided by, once again, anything in the bottom is divided by 300, and I get roughly 0.3248. And for any of our homework, you just need to keep 3 digits, and that should be good enough. So with that, here's your homework assignment. This will be an ideal gas law equation, PV equal nRT. Pick the variable that you're trying to find and isolate it. How many mole? I already have the equation right here, so you're looking for N. It's already arranged by itself. What is the temperature? So here I have to rearrange it by trying to find T. Okay, so one trick is to cross multiply and divide. So D divided by 1 changes absolutely nothing, equal MP over RT. Cross multiply and divide until you get T by itself. And my goal once again is to find what is the temperature, so get T by itself.